Hello dear students, welcome to Gallant IAS. Hope you guys have an amazing day. So today we are going to discuss an important question in CSAT. Okay, so let us check the question. So a man takes half time in drawing a certain distance downstream than upstream. With what ratio of the speed in still water is to speed of the current? So here this question is actually very easy. So this question is actually based on a topic known as boats and streams. Okay, so first of all you need to know some basic aspects regarding boats and streams. I will discuss that here. Okay, so here let the points, okay, let this be the two endpoints of a stream. The stream starts from point A to point B. So let the speed of the stream be VR. That means the stream is actually flowing from A to B. The stream is actually flowing from A to B, and let the speed of that stream be VR. So now a boat is coming and the boat is actually flowing in the same direction that of the stream. The boat is flowing in the same direction that of the stream. That let the velocity of that boat in still water be VB. Okay, velocity of that boat in still water. Velocity of that boat in still water means a stagnant water and the boat's normal velocity. That is actually VB. So VB is the velocity of the boat in still water. VR is the velocity. VR is the velocity of the river, and both are actually flowing in this, the river as well as the boat, the stream flow as well as the direction of the boat, they are actually in the same direction. So this condition is known as what? This is known as downstream condition. So downstream condition is what? When the river, as the direction of the flow of the water in the river as well as the movement of the boat, both are actually in the same direction. That is known as the downstream condition. So this is actually the downstream condition. Okay, downstream condition. Now let us discuss the upstream condition, just opposite to that of the downstream condition. Look here, 2 points A and B. Okay, 2 points A and B. So this boat reached the point B and now the boat is coming back to point A. So the boat reached point B and now the boat is coming back to point A. Okay, boat reached point B, now coming back to point A, and the river is actually flowing. The river's flow is what? From A to B. Okay, so river is actually flowing from A to B. So VR is the direction of the flow of the river, and VR is the velocity of the flow of the river from A to B, and VB is the velocity of the boat in still water, and the boat is moving from B to A. So here you can see that both boat and river is actually moving in the opposite direction. The stream of the water as well as the movement of the boat, they are actually in the opposite direction. This is known as downstream concept. Okay, downstream. That means this boat will be experiencing a lag. This boat will be experiencing a lag force. Okay, so this condition is what? This is known as, this is upstream condition. Okay, this is downstream and this is what? Upstream condition. Okay, so what is downstream condition? Both boat as well as the direction of flow of the river, they are actually in the same direction. That is downstream condition. And upstream condition is what? The flow of the river is opposite to that of the movement of the boat. Okay, that means the flow of the stream as well as the boat's movement, they are in the opposite direction. That is upstream condition. So here the velocity of the downstream condition, let it be V down. Okay, velocity of the downstream condition will be what? Both are actually moving in the same direction, right? So the velocity of the boat will be, if you are checking the resultant velocity of the boat, okay, the downstream velocity of the boat will be what? It will be VB plus VR. The speed of the boat will be increased, okay, with a value which is equal to the speed of the stream. So velocity, that means the downstream velocity is what? That is nothing but VB plus VR. Okay, so downstream velocity is what? VB plus VR. Now consider the upstream case. So here, as I said earlier, this boat will be experiencing a dragging force, right? So whose velocity will be greater, VB or VR? Which velocity will be greater, VB or VR? Of course, VB will be greater. Then only that boat can reach to point A, right? The velocity of the boat, they actually need to overcome the drag force experienced because of this river. So the velocity of the boat will be greater than that of the velocity of the stream. So the upstream velocity will be what? V up. Okay, upstream velocity will be what? It will be what? It is nothing but VB minus VR. So VB will be the greatest velocity. Here VB will be the greatest velocity and VR will be the shortest velocity. Suppose if VR will be the greatest velocity, then that boat, can that boat move forward? No. This river will be taking the boat backwards only, right? Because velocity of the stream is greater than that of the velocity of the boat. But normally in our CSAT questions, the velocity of the boat is actually greater than the velocity of this stream. So then only the boat can move from point B to A in order to overcome the drag force experienced because of the flow of the river. So VB minus VR is what? VB minus VR is the upstream velocity. VB minus VR is what? It is actually the upstream velocity. So VB minus VR is the upstream velocity. So we are saying that the distance between A and B is what? It is D, right? Let me assume that the distance between A and B is D. Okay, so distance is what? Distance is what? It is D. Now read the question. A man takes half time in drawing a certain distance downstream than in upstream. Okay, a man takes half time in drawing a certain distance downstream than in upstream. Okay, so you already know that. So in which direction will the boat will actually take longer time? Either in which direction? Can you tell in which direction the boat will be taking longer time? Upstream or downstream? Upstream, right? Because boat need a longer time, because the boat will have a certain velocity in still water, that is VB, right? But that velocity is, so an energy will be made, right? An energy will be made, but most of the energy produced by that velocity is actually used to overcome the flow of the river, right? In opposite direction. So naturally the velocity of the boat get reduced. Okay, so that means, so here the velocity of the boat get reduced. So the time taken to cover the distance from B to A will be greater that of the time taken by the boat to cover from A to B, because A to B, the flow of river is actually in the direction of movement of the boat, but in case of B to A, it is actually opposite. Okay, so here in the question it is saying that a man takes half time in drawing a certain distance in upstream, right? A man takes half time in drawing a certain distance downstream than in upstream. Okay, so that means a man takes half time in drawing a certain distance in downstream than in upstream. That means let it be T. Okay, let T up be the be the time. Okay, time. Let me write here. Okay, let T up be the time taken by the boat from B to A. Let T up be the time taken by the boat to reach from point B to A. Now let T down be the time taken by boat to reach from A to B. And it is said that the time taken by boat to move from A to B is actually half the time taken by boat to move from B to A. That means the time taken by boat to reach upstream, the time taken by boat to cover that upstream is actually what? Is half. Okay, sorry, the time taken by boat to cover the downstream is half that of the speed taken in the upstream. It's quite natural, right? We already know that upstream is what the time taken in upstream will be greater than that of the downstream. So T up will be what? It will be 2 times T down, right? T up will be 2 times T down. That is, time taken by upstream will be what? 2 times the time taken to cover the downstream. Okay, so this is actually the basic thing that you need to do here. Okay, so T up is what? 2 times T down. Now look here. So here we already know that what is the equation for speed? Speed is what? Speed is equal to distance by time. Speed is equal to distance by time. Here V velocity, okay, that is downstream speed is what? V downstream is what? Distance, that is D, and time is what? Time is T down, right? T down. Okay. Now in case this is actually for the case of, yeah, downstream, right? Now take the case of upstream. In case of upstream, t up is actually the time, and speed is what? Speed is equal to distance by t. So v up is equal to what? V up is equal to d by t up. Okay. So from this equation, t down is what? Time in downstream is what? That is equal to d by v down, and t up is what? T up is equal to d by what? V up. Okay. Now take the condition here. T up is equal to 2 times T down. That means T up is equal to what? T up is equal to 2 times T down. So just substitute the value. So T up is what? D by V upstream, right? D by V upstream is equal to 2 times what? D by V downstream. Okay. So we know that V up is what? V up is equal to VB minus VR, and V down is what? VB plus VR, right? So here, let me write here. So D by VB minus VR is equal to what? 2 times D by VB plus VR. So D got cancelled. Now cross multiplied, right? So VB plus VR is equal to what? 2 into VB minus VR. So VB plus VR is equal to 2 VB minus 2 VR, right? So bring the same terms together. That is VB minus VB is equal to what? Minus 3 VR. So minus minus got cancelled. So VB by VR is equal to what? 3 by 1. So VB is to VR is equal to what? 3 is to 1. So VB is what? VB is the velocity of the boat in still water, and VR is the speed of the current. That means speed of the stream. So the ratio, I think you guys can see this, right? Okay, so let me move this podium to the right side. Okay, so VB is to VR is what? 3 is to 1. So the ratio is 3 is to 1. VB is what? VB is the velocity of the boat in still water, and VR is the velocity of the speed of the current. That means velocity of the speed of what? Speed of stream. Okay, so our answer is what? 3 is to 1. So friends, bot and stream is very important in case of our CSAT. Okay, if you are checking the previous year questions, you can see a good number of questions based on bot and streams. So this topic is very important and very easy to study also. So don't miss topics like this. These are actually the basic things that you only need to know this much things in order to solve question based on bots and strings. If you watch this video, then you actually don't want to refer to anything, because all the basic things I actually explained in this video based on bots and strings. We discussed about upstream condition, we discussed about downstream condition, and this condition is actually enough. Okay, these things are actually enough in order to solve any question based on bots and strings.